Hello everyone. Now we continue our lesson. That's a 2.3. Okay, 2.3 is talking about the series and parallel circuit. For the electricity, they're talking about the buck or the resistor, they how to connect it. So it's separate by two parts. There's a series and also parallel. I think this one your case we also learn about that lah. So I now to continue again. What is that? For this one we got calculation. For your form 1 you learn about that don't have any calculation. Okay, now we go to introduce. You take out your note first. That's a 2.3. Okay, so from here they introduce the first one is a series circuit. Okay, let's see what means of series circuits. Okay, in a series circuit, two or more bulb, you can using the bulb, you can using the resistor. They are connected one end after another. Then after that to form the single of the current flow. Single path for the current to flow. Okay, now you need to see here. Okay, this one is a schematic diagram. We got battery. After that we got two bulb. Can you see the two bulb that join with one of the wire together is one line? So this one we call series. Connected one end after another. After end, then you join another one. So that one we call series. So that means the current also flow in one path only, after that go back. The current must be complete one circuit. If cannot complete one circuit, that means the bulb is cannot light up. That means the current not complete. Okay, this one we call series circuit. Okay, now we go and see the diagram. I will show you the diagram. Here also got the diagram. Okay, this one is an example of the diagram. Okay, after that we go and see the second one. That's a parallel circuit. Okay, parallel circuit, they say all the components they are connected with their corresponding end joint. Every end they will separate. Corresponding end joint, after that separate. How to separate? Separate by parallel. Example, you see this one diagram. Okay, this one also two bulb. Now the two bulb is using extra of the wire to join another bulb. So that means this one is the first part. First part is a series. So they take another wire to join another bulb. So you find out the circuit, they just like the building. One level, second level, third level. So this one is a parallel diagram. So that means the current how to flow. The current start from positive, they go until this part. They need to split up. They need to separate because this one got junction. You need to give first bulb how many current, then you also need to give the second bulb how many current. So this one we call parallel circuit. So there's a corresponding end to join together, after to form the separate and also parallel. So this one is a definition for series and also parallel. Okay, so the diagram here, they will show you how the current to move it. Normally we start from the positive lah. I also will show you one of the diagram. Okay, next, now we need to see is current how to flow. Current flow in series and current flow in parallel, what's the difference? Okay, let's see the first part. First part, I put the ammeter in. Okay, we got 3 ammeter. First one is an ammeter. After the current start to flow, they will meet to the first ammeter. Then after that, they go to the another ammeter. After that, related with the first bulb. Then followed by the another ammeter with the second bulb. After that, the current will go back. So that means now, the current from the first ammeter sure should be the highest because you don't have any resistor. So all the current should be gathered here. So until this part, what happened? Okay, this part, this one ammeter 1, that's read the ammeter is for first bulb. The second ammeter read is for the second bulb. Okay, now the current will start to A, to A1, then go back, A2, bulb, after that go back. Okay, so from here we know the current just go one way only. One way, after that go back. Okay, so from here we find it, the current I1 equal to I2, also equal to the I. What's the meaning? This one we call I, total current. I1 current and I2 current also the same. Although the bulb is different. Maybe this one bulb using 3 ohm resistance. This one is 4 ohm, but the current still the same because you are in series circuit. So series circuit, we don't care you how many resistor. So when you just join in one line, so I give you the current must be the same. So that one is a current characteristic in series circuit. So from here we can write the equation. I means total current. Total current equal first current and also equal to the second current. If you join 3 bulb means I equal I1 equal I2 equal I3. So that one is a current. Okay, so all will get the same current for the series circuit. Okay, now we go to the second one. Okay, second one is a parallel. So second one is a parallel. Can you see? First one, okay, this one is a main ammeter. They want to receive all the current there. Okay, now after the current go, okay, they must go to this part. When go to this part, what happens? They need to split. The current you need to share to each other. So the first one you go to share A1. Okay, after that you go to share A2. And the last one you share to the A3. Finally, after pass to bulb, okay, what happened? They all will come out. All will come out. So after that, they will meet here. Agree? All the current, when they just come out, they will meet at this point. After meet this point, they will go back. Go back to the last one ammeter. So from here, I can say this one should be the highest current. Agree or not? So highest, So from here, this one different with the series. Why? Because series no need to share. One path then go until the end. This one they need to share it. So when they need to sharing, they also need to depends to the bulb how many resistor. If your bulb resistor is high, we're using the formula V equal IR. So V constant. So from here, I and R is inversely proportional. So when you find the R is the highest, if this one R should be the highest, so the current will come here become the lowest. So from here, they share lowest of the current here. Then after that, the rest they will share continue by level to level. So from here we find it, total current equal I1 plus I2 plus I3. So the important keyword is share. They need to share the current in parallel circuit. The second one is they no need to share the current in series circuit. They all will get the same current. Okay, understand? So from here we can see the diagram, these two diagrams. Okay, first one, bulb connected in the series, the current flow through every bulb is the same. Okay, reading for the ammeter I1, I2 and I3 are same. Now we go and see the formula. The formula already given, so remember the formula. Okay, after that following diagram is a current flow in a parallel circuit. So current flow in a parallel circuit, bulb connected in parallel. The current from the battery they need to split, need to share, split into the separate branches. Every branch different. So after that, the reading for the ammeter I1 is to not I1, IT. IT means total. Sum of the reading I1, I2 and I3. So the formula become I total equal I1 plus I2 plus I3. So the two bulb, actually is 3 bulb. The 3 bulb they need to share the main current. So that one is a characteristic for the current, how they flow in series and also in parallel. So I show you the diagram. What is that? Okay, so from here we need to introduce the second one. Current finish. Now we need to see about the potential difference, how to flow in series and how to flow in parallel. Okay. Okay, now we go to draw about the potential difference, go through the series and also parallel the diagram. You can refer your notes. Your note also got. I draw first. Okay, now I show you two diagrams. One is series, one is parallel. After that, both also connected with the voltmeter. Remember, voltmeter, don't care you are series or parallel, they must join with parallel. You see every bulb. Every bulb also join parallel with the voltmeter. Okay, then we go and see the first one. Bulb connected in the series. Okay, potential difference across each bulb is a different. Reading for the voltmeter V is a sum of the reading of the V1 and V2. So the explanation like this. Example total is a 6 volt. Okay, now total 6 volt. Now the 6 volt they go to the series circuit. Okay, they said V1 and V2 they need to share. Okay, now I know the current is the same. I1 equal I2. Okay, resistance is a different, but follow the 6 volt. The 6 volt when they go to the series circuit, they need to share. So that means how to share depend for your resistor. If your resistor you get because constant already, we follow V equal IR. Okay, your I become constant. So that means if your resistance become high, the voltage must be high because this one is a constant variable. So from here we get it. Total 6 volt must be equal V1 plus V2. So this one is a reverse concept with the current. Potential difference in the series, they need to share. Okay, share to each other, but depend for your resistor. Okay, how about the parallel? Okay, we see the parallel first. Okay, current also start to flow. Okay, the current flow is different, depend for your resistor. But voltage, because you can see the voltage, if I close this part, I close it. You see the 6 volt must go to the bulb. Agree or not? Okay, if I close the first part, I connected 6 volt straightforward go to second bulb. They also get 6 volt. Means what? They got personal wire. They got personal wire means you get full voltage. Because you got the wire, you join, okay, you can straightforward to say this part. When until here, I can straightforward come down. I ignore the second bulb. The voltage also can come down, give to the second bulb. First bulb you close, they come to the second bulb also. Means you get 6 volt, I also can get 6 volt. Okay, the bulb is independence. Okay, no need to be, okay, I depend for yours, then you take already, I share the second one. No, they take the full volt. They no need to share. So this one, the voltage should be the same. So the conclusion is 6 volt equal V1 also equal V2. So the concept is exactly opposite with the current. Okay? So for the series, they need to share. For the parallel, everyone get the full voltage. Okay? So this one just a simple of the characteristic. Okay, now we're going to see this one will explain. So also same lah. The first one they show the series. They say the voltage they need to sharing different voltage V1 and V2. So from here the formula they give you V equal V1 plus V2. Okay, the second one they show parallel. Okay, when they show about parallel, they say the same potential difference they across every bulb. Okay, potential difference is a voltage. They go every bulb should be the same. So the formula become equal. All become equal. Potential difference across every resistor in parallel must be the same. So this one just of the two characteristics for the current and also potential difference across the series and parallel. Now we will see some comparison. Okay, comparison for the series circuit and parallel circuit. Okay, before we go to comparison, I want to show you the connection. Connection for the voltmeter in series and also parallel. You can see which one is sharing, which one is no need to see. You also can see the voltage, how to give to the bulb. Okay, you can see. First, okay, finish. Then we're going to see the comparison series circuit and parallel circuit. The first one they say when the bulb in series circuit has blown up. So series circuit example this one. Okay, if this one cannot function. Okay, cannot function, they say what? The other bulb would not be able to light up. So either one just spoil, the other cannot function. Why? Because you see the current will start to flow until this part. You spoil already, then I stop already. I cannot go to the negative. No. They will stop immediately. So this one is when we join with the series, this one is the first of the problem. Okay, so from here you see the B, they say when the bulb they join with the parallel circuit, they say they blow up, either one blow up, the other still can be light up. Why? Because you see the current, when it start to flow until this part, okay? Example, the first bulb cannot function. Never mind lah, the current don't want to flow here, they continue to flow the second level, go to the second bulb, after that the current and go back to negative, so we complete. So that means this one is advantageous when we join with the parallel circuit. Either one of the bulb cannot function, the wire still can continue to be function, let the current to flow to the second level, then after that the bulb can be on. So this one is what's the differences, series and also parallel. Okay, you can refer the diagram I show you what's the difference when parallel and also when series. Okay, and the last one, every time they will ask the same question. Series and parallel, also two bulb. Now they will ask you which one bulb become lighter, brighter also. Both diagram also can be light up the bulb. Then they ask you which one become brighter. Okay, so from here we need to explain. The bulb in the parallel circuit light up brighter as compared to the series circuit. Why? This one is another thing. Bulb is the same one. Resistor also say, why you say parallel should be highest? Okay, now we go to explain first. Okay, then we need to say about the earlier that 2.2, what we learn. We learn about current, we learn about the charge, we learn about the voltage. So I told you must have the voltage first. They're from the battery. So battery got voltage, they got work done to move the charge to flow. Okay, electron. They start electron to flow, then you produce a current. Is it? So from here we're talking about the voltage. Voltage is the main final current to come out. So from here we compare here. Okay? So this one volt 6 volt. Until I come to first bulb and second bulb, I need to share. So if I say two bulb is the same, this one take 3 volt, this one take 3 volt. Agree? Okay, but when I go to this part, the volt no need to share what? You get 6 volt, I get 6 volt. So understood. Which one volt become highest? This one volt become highest one. So this one volt is higher, you are the winner lah. We don't care about current already. So you get 6 volt, but sure the current become highest lah. Agree or not? So from here, this one volt should be highest for every bulb. So you can get the brightest compared to the series. Important is the voltage. Okay? So from here, they also explain for you, in parallel circuit, the voltage across every bulb is higher as compared to the voltage go to the every bulb in the series circuit. So from here, the bulb light up brighter, indicate the current that pass through is larger. If your voltage become highest, understood, your current go there also highest. Okay? If the resistance is a constant. Okay? So V equal IR. If your R is a constant, if your V become highest, understood, your current also highest. So that means, if you connected in the parallel, first one, advantageous, one of the bulb blow up, the other can function. Second one is, the bulb, you get it become brighter compared to the series circuit. So this one is a comparison for the two different circuits. Okay? I can show you the diagram, you can see about that. What's the difference for the bulb in series and also in parallel when they just on together. Okay, clear? So now, after finish all the explanation, then this one topic, we got calculation. Your most favorite question, there's a calculation. So before calculation, sure got formula. Okay? So from here, wait a while, you can read first, then clean first. Okay, can you see the formula here? Formula also same, they separate by series and also parallel. Same like what I told you just now. Okay, we see the series first. Okay, the series. Before that we say current, is it? The current I total. Okay, for the series they no need to share. I1 equal I2 equal I3. So this one is a series. Okay, voltage. Potential difference total. V1 plus V2 plus V3. Okay, this one is a series. Okay, one more resistor. Okay, now we extra one more. Okay, example is the resistor that connected in series. So this one we call R1, R2, and R3. Okay, how to find the total resistance? Total resistance for the series easier only. Just plus. Total resistance equal R1 plus R2 plus R3. Okay, sometimes the question they don't say total resistance, they say effective resistance. So effective understood overall. Okay, overall resistance. Okay, this one is a series circuit. Now we're going to see the second one. That's a parallel. Okay, the parallel. Okay, parallel circuit, I total, they need to split out. So we need to split up. So we plus. Okay, voltage total, this one is everyone they get the same voltage. Okay, now is the resistance. Okay, we see the resistance first. Okay, if the resistance they joined by parallel. This one is an example for the resistance they joined by parallel. Like this. So this one is R1, R2, R3. And they ask you what is the effective resistance. So your formula, the formula for the R total equal 1 over R1 plus 1 over R2 plus 1 over R3. Okay, finally, I want to find is the R total. So that means your answer must be reverse terbalik. The RT must be up. Example, excuse me. If I get my answer, 1 over RT equal 3 over 2. Okay, this one no answer because they want to find R total. So that means you need to reverse. R total equal 2 over 3. Then you need to press your calculator, get in decimal point. Because they cannot accept the answer in fraction for physics. So this one is final answer. Okay, this one is a formula for the parallel circuit and also for the series circuit. Okay, any question? I think no, is it? Just a simple thing. You also learn during your KH Kemahiran Hidup. So from here we need to find out some of the difference for the formula. Okay, let's see here. This one is the lowest part. They say the hint of the circuit. Okay, before we go to the some shortcut how to do the calculation, okay, I want to introduce a little bit for you faster to do the calculation. Example for parallel. Okay, faster. Okay, let's say example like this. Okay, this one is a parallel. I got two resistors. Two resistors also 8 ohm. Suppose you're using this formula, yes or no? 1 over 8 plus 1 over 8. After that plus together, then you terbalik. Suppose this one simple only. We don't need to do long calculation. You straightforward take 8 over. Okay, you got how many resistors? 2. Divide by 2. So your answer is a 4 ohm. It's the same thing. Okay, example, I do the long one. 1 over 8 plus 1 over 8. There's a 2 over 8. After that, you need to terbalik. Terbalik become R total equal 8 over 2. And then become 4. It's the same thing. Okay? So if I got 3 resistors, then how? 8 divided by 3 lah. This one, when we can use? When all the resistance is the same. If the resistance different, you cannot do like this. Okay? So I show you another method. Okay, if I say this one is a 4 ohm. Okay, it's a 4 ohm. Normally how to do? You also same lah. 1 over is it? Okay, I do the long first. 1 over 8 plus 1 over 4. 4 you need to times 2, is it? 4 you times 2, this one times 2. So you become, this one become 8, this one 2, 3 over 8. Then you need to terbalik. So the R total will become 8 over 3. Then you press your calculator, you get the decimal point. Okay, if not, we also can using the short one. Okay, we straightforward do the calculation. Okay, we take this one 1, this one's a 2. R1, R2. So suppose the formula is R1, R2. R1 plus R2. Suppose the calculation like this. Okay, normally you make the bottom become the same, is it? So bottom become the same means you multiply lah. When you multiply, finally you do the balik. So I put the R1 and R2 at the top. Then plus 1 at the bottom. So from here, follow this one calculation. 4 times 8. How many? 32. Okay, over how many? 4 plus 8. That's a 12. So you get the answer also the same. There's an 8 over 3. It's the same answer. Okay? Or you straightforward press your calculator because the calculator very fast already. 1 over 8 plus 1 over, you can get straightforward get the answer. Okay? If you show, you need to show the calculation. This one is how you get the mark in structure question. You need to show. Okay? Show the work how you do. Cannot straightforward give the answer, then minus your mark. Okay? So this one is a short form. Okay, then we need to go is important at the bottom here. Because say hint of the circuit. Okay, current divider. What situation we using current divider? When there is in parallel. Okay, in parallel. After that, the question never provide voltage. This one we call current divider. They never provide the voltage, so that means V equal IR. Okay, they just give you the current, they give you a resistance. The problem is now your current need to separate because there's a parallel I1 and I2. Then suddenly the question says, okay, fly the first one. What is the current when they go to the first resistor? The question never provide voltage. So this one we say current divider. So for this one situation, you also can do the long one. Up to you. So it follow like this. Okay, then from here there's a I1. This one should be the I2. Okay, now the question they never provide any voltage. So they want you to find I1. I1 is how many? Okay, you can do the long one. I never say you cannot. You can do the long one. Okay, but from the long one, you can create the formula so it become faster. So from here, the long one is how? The long one, you're still using V equal IR. Okay, then from here, you find total R low. After total R, then the current provided, the current show will provide the one of the current. Then you find the V. After find the V, okay, one by one to solve the problem. Okay, V first one. V equal IR, then V equal IR, then find what is the I, what is the I2. Okay, this one is the way you can solve it because the voltage is the same. Okay, so from here, example, I give you the number we do first. Okay, this one is a 4 ohm. This one is a 3 ohm. Okay, then I give you the voltage, current is a 10 ampere. So how to do the calculation? Straight. We find out what is the R first. So your R is, V do know, I is 10. Okay, your R is 3 times 4. 3 plus 4, 7. Then you find your voltage, is it? Okay? After you find your voltage apply for the first circuit because V is the same. The voltage V equal IR, you solve, you find the I1. Or you take the V, you solve the second part, V equal IR, the R is here, then you find I2. This one is the long method, how we solve it to find I1 and I2. If you do one, you can straightforward apply the formula. Okay, let's see the formula how to apply. If you want to find I1, the formula is R2. R1 plus R2 multiplied with total current. This one is the first formula you find I1. Okay, if I2, R1 plus R2 multiplied with I. Okay, see the difference, If you're using 1, this one must be 2. This one using 2, this one must be 1. Why become like this? Because V equal IR. I and R is inversely proportional. So they cannot use become the same type. They must have the difference. Okay, so if anybody, you want to know this one, how to prove, you can ask me. I will show you in diagram. If you want to try yourself, you also can do by yourself. This one formula actually is from the long method. After that, we create the formula to come out. Okay, so if you just want to faster, we straightforward to apply. Very fast. This one is not very fast. You can straightforward to get the answer. Make sure your memorized formula must be correct lah. Don't be terbalik. Okay, this one we call current divider. Now we go to second part. At the bottom one. The second part is say voltage divider. Okay, voltage divider is when they're in series. In the series, this one is R1, then this one R2, then they got voltmeter V1, then this one is V2. Okay, this one situation is the question never provide current, never provide the current, but they got tell you overall the V is how many? They got tell you 6 volt. Example 6 volt. Then the question is, please find what is the V1. Okay, V1. Okay, because this one is a series one. Series means the voltage you need to share it. How to share it? You depend the resistance. Okay, the problem here, no current. You also can using the long method. The long method is 6 volt equal. Okay, this one R1 plus R2. Okay, multiply the I. You find out what is the I first. Okay, when you find out the I is how many? The I pass through R1, the I pass through the R2 should be the same because there's a series. Then again, you're using the same part for the first situation. V equal IR, find what is the V1. The second part also same, V equal IR, find what is the V2. This one is a long method. Okay? So now we go through to the short method. Follow the formula here. So the short method, because V and also the R is directly proportional when the current constant. So we can straightforward V1 equal R1. R1 plus R2 multiply with the V. Total V. V2 is a R2. R1 plus R2 multiply with the V. So this one is a formula for the voltage divider. Also say, if you want to prove, you can prove yourself. If you don't want to prove until end also cannot, so you can ask me, I will show you. Okay? So this one is a formula for your faster to do the calculation. Okay, the last one is a short circuit. You see the short circuit, what's the meaning? Short circuit is when the current go, okay, one got resistance, and then that one is nothing. So this one we call it short circuit. The current very pandai one. They don't want to find the problem. You got something to block me, why I want to go there? So better I find the easier way to go. Then they must go to the find another way, that's empty one. So they can straightforward to go. If you put a bulb here, means the bulb cannot light up. So this one we call short circuit. Okay? So we got 3 of the hints only. Okay, understand? So from here, the lesson should be finished. So I do the example question first. So example, here got 3 examples. We can try one by one. Easier question also. Now we try example 1 first. Okay, let's see the example 1. They call you to determine the effective resistance for following circuit. So from here, find all the resistance. So let's see the A. A easier because there's a series. So A, the answer we just plus together lah. 20 plus 10 plus 5. Remember the unit, there's a 35 ohm. Okay, so this one is an A. Okay, let's see the B. B all is a parallel. Okay, then I told you all parallel, after that all is the same resistance. So 8, 8, 8. What to do? We take total resistance is a 8 divided by 3. So become 2.67. 2 decimal point. Okay, in decimal point. Don't put in fraction. Okay, now it's a C. C, you tell me. Okay, I draw first. 10 ohm. Then we got 20. 20 ohm. Okay, after that we got parallel. This one is 8, this one is 8. Okay, which part should be settled first? Okay, can I say, okay, 10 plus 20, then I plus 16 lah. Cannot what? You cannot say, okay, 30, then 38, and then baru can do parallel. No. So for this one situation, we need to solve this one first. We solve this one situation first. Okay, when I solve this one don't see first. This one is a parallel, is it? Okay, when I solve parallel 8, 8, then 8 divided by 2. This one becomes 4. Agree or not? Become 4 ohm. So now I redraw the new one. 10, 20, then straightforward this one become 1 already because combined it becomes 4. So total 34. Okay, just a simple question. And the last one, D. D is all parallel. Okay. In the center they got another one. The last one. Okay, 8, 8, and 8, then 4 and 4. Okay, now how we solve it? Now we solve the series first or solve the parallel first? We need to solve is the series first. So from here we combine these two, become 16. Okay, we also want to combine these two, become 8. So from here I redraw the new one. (16), 8, and 8. Okay, so from here I need to solve the problem. I solve these two first because these two is the same, 8 and 8, so become 4 divided by 2. So I solve it, become shorter some more. Now I left is a 2 only. Okay, this one become 4 already. This one becomes 60. Okay, so finally I left 2 more. Then we straightforward apply the short calculation. Okay, the short calculation is straightforward. Take 16 multiply with the 4. 16 plus 4. So we get the answer become 3.2. Okay, so this one is a 4 question answer. Okay, then we go and see example 2. Example 2, they want to find reading of the ammeter. So you circle the ammeter, they want to find ammeter, they don't want to find resistance. They want to find ammeter. So you need to see where's the locator for the ammeter. For the A, okay, let's see for the A, 20 volt, we want to find what is the current. So we still using V equal IR. This one we solve first. This one become 4. This one become 4. Agree. Then 4 plus 8 will become 12. Okay, so we solve it. V equal IR 12. Then the I is how many? So we get it, the I will become 1.67 ampere. So this one is the first question, we find the current. Okay, let's see the second one. Okay, this one is the second one. Okay, second one they want to find is I1 because the ammeter is here. So we take this one as a 1. Okay, what we need to do, we need to find total I. Okay, from here we still need to using to find the total I. Remember the formula for current divider. We also need to find out total I is how many. Okay, so from here find resistance first. These two will become 1 ohm. So total is 9 ohm. Agree? So V equal IR 4.5. I do know. Okay, 1 plus 8, 9. So we find it, the current is how many? Total current you get it, that's a 0.5 ampere. This one we call total current. So this one is total current. Now the current go to the first one. It's the same. This one 8 ohm also gets 0.5. Agree? Then they go to this part. When they go to this part, they need to split. Agree or not? Because there's a parallel, you need to split. Okay, how they go split? Depend resistance. Now is it 2 resistance also 2 ohm? If 2 resistance also 2 ohm, then we just divide by 2 lah. Because your resistance is the same. So we just share same for you both. So I take it, I1 is a 0.5 divided by 2. So the answer 0.25 ampere. Okay, this one is the second one. Okay, then we go to third one, that's a C. Okay, you can try yourself first. I clean the box. Okay, this one is a C. Okay, let's see the C. So we need to solve with this one. Okay, the question also same, they want to find I1. Okay, I1, then they give you the voltage is a 24. Okay, also same, don't have total I. So we need to find what's the total I. Okay, this one we solve it. Okay, total, this one I want to cancel. This one will become 6 times 2 divided by 8. Okay, so I find the resistance become 1.5. Okay, this part will become 1.5. Okay, then all become series. I plus together. Total resistance now is how many? Total resistance now is a 12 ohm. So apply V equal IR, 24, I, 12. So I'm getting I is 2 ampere. Okay, so that means the current that passed here, there's a 2 ampere. So when the current pass 2 ampere means you get 2 ampere. Then until here also 2 ampere, but now they want to split I1 and I2. The problem now, 6 and 2 is a different. So we cannot say same like just now divided by 2. Now we need to split. So from here we're using voltage divider. Okay, to do the current divider to do the calculation. Okay, current divider, so I take this one is I1. So remember, I1 equal R2 first. This one is R2. And the rest don't see. These two don't see already. We just see this part. So now is R2 is 2. R1 plus R2, 6 plus 2. Multiply total current, 2 ampere. So you find it, I1 is how many? The I1 will become 0.5 ampere. Okay, so this one I told you why it become fast. Because I'm using the formula. If not, you one by one do the calculation. You need to find what's the voltage here. Then Baru can find the I1. So this one is a long method. Okay, then we go to the third part. That's example 3. We need to find the voltage for the different voltmeter. Okay? Okay, you can try first. You can do the 2 example question later. Okay, now we're going to see the example 3. Okay, we solve the first one. This one we assume there's a V1, this one is a V2. Okay, depend for yours lah. I want to see the first one, then I assume the one is a number 1. Okay, so from here I find it. We don't have any current. So you want to using the long method is okay. You find the 24 equal IR. The R is become 12. Then you find the current, then one by one solve it. Okay, now I straightforward using the formula to find what is a V1. So your V1 is R1. R1 is this one, 8 over 12. Multiply with 24. So I straightforward to get my answer, there's a 16 volt. Okay, so this part also same. This part also same. They want to find the V. Okay, we assume this whole thing is a V1. And this one is a V2 lah. If I put the voltmeter, that one become 2. So this one overall become R1. So I need to solve the R1 first. I need to find out total R1 actually is how many. So the R1 is 12 multiplied to the 4 divided by 16. So I'm getting my R1 is 3 ohm. Okay, I get 3 ohm first. Now I need to do the calculation for overall V1. Also using voltage divider. V1 equal R1. R1 overall 3. R1 plus R2. 3 plus 9. Multiply total V 6. So my answer is 1.5. Okay, so this one is why I say I want to use formula very fast. Straightforward, I can do the get the answer. Okay, so this one all is example question. So everyone, you need to do is your example. Finish all the example for calculation. Then after that, answer the question for the structure. Okay, there's a question 13 and 14. Okay, for the student you get 15, then you continue for 15. If don't have, then you don't need to do lah. You until 14 only. So the rest I will continue my tutorial. I will show you the answer. Okay, so this one just a simple. So hopefully you can understand what I'm talking about that. Okay, so you understand. So thank you everyone for the lesson. Now you need to continue your tutorial. Okay, thank you.